Inshallah, we are going to continue the fifth type of higher order linear differential equations. Now see here, when we have to use this method means we are having some function, other function with x, with this algebra. If we are having algebra x into some function, then we have this formula. Particular integral is x minus, we have to use this formula, x minus f dash d by f of d into 1 by f of d into v. Now x is gone from here. X is here. X minus, what is the formula? F dash d by f of d into 1 by f of d into v. When we have to use this formula, we are having x and some other function. X minus f dash d by f of d into 1 by f of d into v. So let me continue a few questions based on this formula. Now see here, we have to find the particular integral. Let me do one thing, bring this on the other side. What will you have? Y equals to 1 divided by d square plus 2d plus 1 into y. Sorry, into x cos x. X cos x. Now just know we have understand this method. X into some function means we have to use this formula. 1 by f of d x into, the formula is x minus f dash d divided by f of d into 1 by f of d into what is remaining v. So this is the formula we have to use. Now watch here carefully. Here you see here, this is f of d. Let me write this. What is f of d we are having? Whatever this is f of d. So this is d square plus 2d plus 1. So what will be f dash d? Differentiate this one. If you differentiate d square, differentiation will be 2d. Differentiation of d is 1, 1 into 2 is 2, constant is 0. So let me use this formula, therefore yp integral factor equals to x minus f dash d. The value of f dash d is 2d plus 2 divided by f of d. The value of f of d is d square plus 2d plus 1 bracket, okay, into 1 by f of d. F of d is d square plus 2d plus 1 into what we are having, v. V means here cos x. Now let me continue from here. See, let me solve this afterwards. Let me first solve this one. In this we are having cos ax. For sin x and cos x, what we have having the method d square equals to minus a. Let's first we solve this one, then we go inside. Okay, equals to minus a cos ax. In place of a you are having 1, minus 1 square is 1. So in place of d square we have to keep 1. In place of d square we have to keep 1. You write the remaining terms as it is, x minus, write this as it is 2d plus 2 by d square plus 2d plus 1 bracket, okay, 1 divided by, in place of d square if you keep minus 1, minus 1 plus 2d plus 1 cos x. Minus 1 plus 1 cancel. What we have left with 1 by 2d cos x. Okay, we can take out 2 outside. Let we keep this 2 outside the constant. We can keep outside. Now 1 by d of cos means integration of cos. Now integration of cos will be sin x. So let this be the rough work. Okay, so this 2 you take out 2 here outside, 1 by 2. This 2 I have written here. Now what is left here? X minus 2d plus 2 divided by d square plus 2d plus 1 into bracket. Now 1 by d cos means integration of cos is sin x. So let me write this sin x. Now let me continue this one. You see here, you multiply with x into sin and this into sin. So we are getting two values. X into sin will be x sin x minus, you multiply this one, 2d plus 2 by d square plus 2d plus 1 into sin x. Again for this, if we keep d square equals to minus 1 square minus 1. Minus 1 plus 1 will get cancelled, left with d, 2d. So I'm writing here 1 by 2 into x sin x minus, you write this as it is 2d plus 2 by, if we keep minus 1 here, minus 1 plus 1 will cancel, what we get? We left with 2d sin x. Again you see 1 by d means integration of sin will be minus cos x. Minus on us we can write plus cos x. You see here, If we keep minus 1 here, minus 1 plus 1 get cancelled, we left with 2d. You write 2 as it is. 1 by d means integration. 1 by d of sin x, it is like this. 1 by d of sin x is minus cos x. We're already having minus here, so minus 1s will become plus cos x. So let me write here equals to 1 by 2 into x sin x minus 1s plus 2d plus 2 into cos x. 1 by d means integration of sin is minus cos x divided by 2. Let me do one thing. If you take 2 common, you get 2 and 2 will get cancelled. Let me take 2 common here, it will be d plus 1. If you take common, it will be d plus 1. So we cancel this one, 2 to cancel, now multiply with d and 1 like this. 1 by 2 into x sin x plus d into cos x, d cos x plus 1 into cos x, cos x. Now d by dx of cos x is minus sin x. So 1 by 2 into x sin x minus sin x plus cos x. Now last step, just to take my sin x common from the 2, we can leave here yp equals to 1 by 2 into, if you take sin x common here, you left with x minus 1 into sin x. Sin x you have taken common, x is left, sin x taken minus 1 plus cos x. So this is the method when you get some function, other function with x. Now see here next question. We are having three variables x, e power x, sin x. Let us solve that afterwards. Solve means we have to find both particular integral and complementary function. First we write this in the capital D form. This is d square minus 2, this is d plus, you have taken by common from all, this is plus 1, you have taken by common, so this will be x e power x sin x. So let me take first auxiliary equation is, this is m square minus 2m plus 1 equals to 0. You take from the calci or you factorize, okay, you get like this, m minus 1 into m minus 1 equals to 0. Therefore m equals to 1 comma 1. We are getting repeated roots. Therefore complementary function is type 2. Those who don't know about complementary functions, they see they try to see the part 1. Part 1 I have explained all the methods, okay. So complementary function is yc equals to, since m values are same, we are having case 2, c1 plus c2x e power mx. Here m value is 1, so 1 into x will be x. So we got this yc equals to c1 plus c2x into e power 1x means x. Now for particular we have to bring d that side, so y equals to like this, 1 by d square minus 2d plus 1 bracket x into e power x into sin x. Now see here, this is a combination of type 4 and type 5. We have to take out x also, we have to take out e also. First I am taking out e outside. We already studied now this formula, 1 by f of d. In the type 4 we have did this one, e power ax into, if we take out e outside, this d will become d plus a, this d will become d plus a into v is left. So let me take out e outside. If we take out e outside, we have to write d equals to d plus a equals to d plus a sin ax. A is here 1, sin ax, compare a is 1, so in place of d we have to write d plus 1. Therefore now let me write d plus 1. Therefore particular integral yp equals to 1 divided by, in place of d we have to write d plus 1 whole square minus 2 into d plus 1 plus 1. Now see here, e is taken out, e is here suppose. Now what is left here, into x into sin x into x into sin x. Let me take this out offset side. First we solve this one. Yp equals to e power x into 1 will be e power x divided by d, expand this one, this will be, let me write this outside, okay, let me write like this, equals to e power x into, it's better if you write like this, okay, into 1 divided by, now expand this one, a plus b whole square is a square plus 2e2 into d 2d plus 1 plus 1 minus 2 plus minus 2d minus 2 plus 1 into, what is left here, x sin x, x sin x. Once more you see a plus b whole square, a square plus 2e, 2 ones are 2d plus 1 square 1 minus 2 plus minus 2d minus 2 plus minus 2. You see here we get cancellations here. We get cancellations here. What's the cancellations here? Plus 2d minus 2d cancel, 1 plus 1 2 plus 2 minus 2 get cancelled. Now what is left here? Yp equals to e power x into 1 divided by d square into x sin x. Now see here there are two methods. One thing is double integration, d square means integration of integration, that will take lengthy because we have to multiply this two. Now you suppose this as f of d. What is the method we are having? 1 by f of d x into some function, x into some function. This formula is x minus f dash d by f of d bracket. Now x will be gone outside. What is left here? V. So let me use this method. For this method, this is considered as f of d. So f of d we are having d square. To differentiate this one, f dash d will become d square differentiation is 2d. D square differentiation is 2d. So let me use this yp equals to, already we are having e power x outside. Now what is the formula here? X minus f dash d. F dash d is 2d divided by f of d divided by f of d. F of d is d square. F of d is d square into x minus f dash d by f of d into, again we are having f of d into 1 by f of d. F of d is here d square into v. Now x is taken outside. Now what is left here? V means here sin x. Now here we have to change the sin x. For sin x or cos x, we know d square equals to minus a square. Minus 1 square is minus 1. So in place of d square, we can write minus 1. Okay, this place is less here. I have wrote this out here, written this here. So in place of d square, if we keep minus 1, 1 by minus 1 be minus. So I am taking out minus outside. Okay, so we can write like this: yp equals to minus 1 by 1 minus 1. This minus is written here, minus e power x, x minus this d and d will get cancelled. What is left here? 2 by d into sin x. Now let me do multiply this x into sin x, 2 by d into sin x. Okay, now two steps are left. Yp equals to minus e power x into, if you multiply x into sin x, this is x sin x minus 2 by d into sin x. Now last step is left. Watch here. Now this 1 by d of sin x means integration of sin x. Wherever we get 1 by d, we must understand this is integration. So 1 by d of sin x is nothing but integration of sin x is minus cos x. Again, if we bring here minus, it will be minus on us plus. So what is left here? E minus e power x into x sin x. Integration of sin x is minus cos x, so minus on us plus 2 cos x. So this is the particular integral. This is the particular integral. Therefore, what is our formula? Therefore, we have to write complete solution. We have to write complete solution. Therefore, let me write here. Complete solution is y equals to yc plus yp. Y equals to yc, just now we got this yc. So the value of yc is c1 plus c2 x into e power x plus yp. Yp, just now we got this answer. This value is here minus x minus e power x into minus e power x into x sin x plus cos x. X sin x plus cos x. If you want to solve one more step, you can take e power x common, only it can leave here. So this is the solution. So inshallah we will continue in the next class to practice this type of questions, one or more questions, few more questions of the same type from the textbook, so that you will get perfection on the topic. Inshallah, in the next class we are going to continue with the variation of parameters, which is very important topic, how to solve the different linear differential equation of secondary using variation of parameters. Inshallah, we will continue in the next class.